Hi everyone. In today's video, let's cover a subtopic of matrices and determinants, which is related to minors, cofactor, and adjoint of a square matrix. So let's go through this particular subtopic. What is minor of a matrix? Minor of an element in a matrix is nothing but the determinant obtained by ignoring the row and column in which the element aij is present. Similar to determinant, right? In determinant, suppose let's take this as an example. In this example, we want to find the minor of this element. So minor of 3 is nothing but ignore the row and column in which 3 is present. So ignore this row and this column. So what are the elements we have? We have 2, 0, minus 3 and 4. 2, 0, minus 3 and 4. These are elements that we have. Now we calculate, that is we cross multiply, we calculate the determinant. Nothing but 2 into 4 minus 3 into 0. This is how we calculate determinant, correct? So 2 4s are 8 minus 0. So we get 8. So 8 is nothing but the minor of this element 3. Let's take another example. Say, let's find minor of element 0. Ignore the row and column in which 0 is present. Ignore this, right? So what are the elements left? Elements left are 3, minus 4, 5 and minus 3. Now we calculate the determinant, that is cross multiply. 3 into 3 is minus 9, 3 into minus 3 is 9, minus 4 into 5. So we'll get minus 9 plus 20. So we'll get 11 as the answer. So 11 is the minor of element 0. Now what is cofactor of an element? What is a cofactor of an element? Cofactor of an element is same thing as minor itself, but with a proper sign, right? It is minor of that particular element with a proper sign. Now, what do you mean by proper sign? Sign is nothing but, so we know that every element in the determinant will have alternate signs. So it will be plus, minus, plus, minus, plus, minus, plus. So this is how you alternate the signs for elements in the determinant, right? So you apply this particular sign. Now, take the same example, minor of 3. Minor of 3 is 8. Where is 3? 3 is here, right? This is the element. What is the sign? What is the sign for this particular element? Minus. So you put minus here. So cofactor would be minus 8. Let's find cofactor of 0. For 0, what is the sign that is there? It is plus over here, right? This is a sign. So it's going to be plus 11. Plus 11. So this is the cofactor of 0. This is an easy way to remember the signs. That is, you start with plus and then keep alternating with minus plus for every element. The actual method is this one. That is minus 1 into I plus j, which is you put minus 1, I plus j is the row number, I is the row number, j is the column number. Now you take this element 3. What is the position of this element 3? Right? It is second row. That is second row, first column. This is how you represent. If A is an element, the position of that particular element in the matrix is given with ij, is given as I and j. I is the row and j is the column. 3 is in second row. So I is 2 and it is in first column. So j is 1. So now what you'll have to do? Minus 1 I plus j. So it is 2 plus 1, which is 3. So minus 1 to the power 3. So if you multiply minus 1 3 times, minus 1 into minus 1 into minus 1, it's going to be minus 1. So basically the sign is minus. So we have minus here, correct? Similar, instead of doing all of these calculations, it is easier to remember this alternate way of putting signs instead of calculating I plus j for every element, right? We also found the cofactor of 0 here, right? Cofactor of 0 is plus 11. How did we get plus? Because 0 has a plus sign here. But how did we know that this is a plus? How did we know? It is using this formula, minus 1 to the power I plus j. Now 0 is in which position? 0 is in first row. That is I is equal to 1. Third column, j is equal to 3. Now, so this becomes minus 1 into 1 plus 3, which is minus 1 to the power 4. So, since this is an even power, when you multiply minus 1 4 times, it's going to be plus 1 itself. So, the sign that you get is plus. That's how we arrived at this plus sign here. To make it easy, right, if you just remember this particular sign concept, that every element has alternate signs, you can avoid all this I plus j calculations. Let's find few more minors and cofactors of few elements in this particular determinant. Let's do that. So let's say we want to find minor of 2. We want to find the minor of this particular element. So what we'll do, we'll delete this particular row, delete the column in which it is there. So what are the elements you have? You have 3 minus 2. The elements you have is 3 minus 2, 5 and 4. So now we'll multiply, cross multiply 3 into 4 minus 2 into 5, which is 12 plus 10, 22. 22 is the minor. Now what is the cofactor? Cofactor of 2. Cofactor of 2 is the minor itself but with proper sign. Now what is the sign for 2? 2 is in the second place. So it is nothing but plus minus plus. So it's minus. So it's going to be minus of 22. This is the cofactor, right? If you use the alternate method, that is minus 1 to the power I plus j, you will get minus 1. What is I? What is the row count? What is the row position for 2? For 2, the row position is first row and column is second column. So it's going to be 1 plus 2, which is minus 1 to the power 3. So since it's an odd power, if you multiply 3 times, you're going to get minus 1. That is, you're going to get minus as the sign. Therefore, the minor 22 will have this minus sign. This is an alternate way. Now, what is adjoint of a square matrix? What is adjoint of a square matrix? Say you have a matrix, right? You fill that matrix with all the cofactors. You fill the matrix with all the cofactors and then take a transpose of it. That becomes the adjoint. So adjoint is denoted like this, right? You tell adjoint of matrix A as ADJ and the matrix name. This is how you represent adjoint. Now, adjoint is nothing but cofactors of each of these elements. You find the cofactors of each of these elements, right? Put those cofactors in this particular matrix, take a transpose of it, then it becomes the adjoint of matrix A. Now, we'll have to go one element by one element. You'll have to find cofactor of 1. What is cofactor of 1? Cofactor of 1 is, ignore this row, ignore this column. What will be the cofactor? Cofactor, what are the elements? First, let's write down the elements. Elements are minus 2, 0, 5, minus 3. Right? These are the elements. Here, we are clubbing minor operation and putting a sign to it, like this. Here, what we did to find the cofactor, we found the minor, then put the sign to it. Right? Now, we'll club both of this and find the cofactor. So, basically, you find the elements, then now you apply the sign. So, we can populate the signs initially itself. What are the signs? Plus, minus, plus, minus, plus, minus, plus, minus, plus. These are the signs, right? We have populated it. Initially itself we populated. Now we go on putting the minors. Now we'll go to the second element, minus 1, right? For second element, you'll have to ignore the second column. So what are the elements left? Elements are 3, 0, 4, minus 3. 3, 0, 4, minus 3. Now we'll go to the third element. Third element is, we'll have to ignore third column and first row. These are the elements. 3 minus 2, 3 minus 2, 4 and 5. So let's go to the fourth element now. We'll find cofactor for 3. Cofactor for 3 is, ignore second row, first column, right? Now what are the elements left? Elements left are minus 1, 2, 5, minus 3. Minus 1, 2, 5, minus 3. Similarly for fifth element, minus 2. For minus 2, ignore this second column. So what are the elements? 1, 2, 4, minus 3. Let's find for the sixth element. For sixth element, you ignore, sixth element is 0. So you ignore the third column and the second row. So what are the elements we have? We have 1, minus 1, 4 and 5. 1, minus 1, 4 and 5. We'll go to the sixth element. That is this element, number 4, right? Here what we're going to do, ignore this particular row, this particular column and this particular row. So we're going to have minus 1, 2, minus 2, 0. Minus 1, 2, minus 2, 0. The next element is 5, right? So we'll ignore the column in which 5 is there and row. So we're left with 1, 2, 3, 0. 1, 2, 3, 0. So we'll go to the last element, which is minus 3. Minus 3, we'll have to ignore the last column and the row. So what are the elements we have? 1, minus 1, 3 and minus 2. What we have done is, we have filled everything with cofactors. But we just have to calculate each of this. That is cross multiply, subtract. Cross multiply each of this, subtract, right? And then apply these signs. That will give us the cofactors of this entire matrix. Then we'll take the transpose. So now let's calculate everything one by one. So let's calculate it here itself. So we'll get minus 2 into minus 3, which is plus 6. 6 minus 0. So you'll get 6 here. Then 3 into 3 is 9. Minus 9 minus 0. So you'll get minus 9 here. And do not forget, we'll have to put this minus also. So when you multiply this minus and minus, it's going to become plus. Now similarly, we'll find for this. 3 5s are 15. 15 minus 8. There is minus here. So minus of minus. 15 plus 8. So 23. And this sign here. Plus 23. Now for this element, minus 1 into minus 3 is plus 3. Plus 3 minus 10. Plus 3 minus 10 is minus 7. And then we have already one minus here. So it's going to be plus 7. Then similarly here. So minus 3 minus 8. You're going to get minus 11. Then 5 minus of minus 4. So 5 plus 4, 9. And then there is minus here. So minus 9. Similarly for the third row, you'll get 0 plus 4. So for this one, 0, 0 minus 6 and minus is here. So plus 6. And this is minus 2 minus 2 plus 3, which is 1. Now let's write all of these elements. We'll have to find the transpose also, right? So we'll interchange all the rows and columns. So that will become the transpose, right? So adjoint A is nothing but 6 9 23, 6 9 23, 7 11, 7 minus 11, minus 9, 4 6 1. So this is the cofactors. Now you find the transpose. So transpose is just interchange the row and column. So this row 6 9 23 will make it as column. 7 minus 11. So 7 minus 11 minus 9, 4 6 1. So this is the adjoint of A. Now let's find the adjoint of 2 by 2 matrix. So this is far simple, right? It's not as lengthy as a 3 by 3 matrix. For 2 by 2 matrix, let's go through how to find adjoint. Same concept. So find the cofactors of every element, right? Now let's find the cofactors one by one. So let's take the first element, which is 1, right? 1. Now ignore the row and column in which 1 is there. So if you ignore, you're left with element 0. And what is the sign? Sign is plus. So plus 0. Then we'll go to the second element. Second element is minus 3. This is minus 3. What is the cofactor? Eliminate the row and column. You're left with 2. And what is the sign? Sign is minus 2. Now we'll go to the third element, 2. So for 2, ignore this column and this row. So you're left with minus 3, right? And what is the sign? Sign is minus. So minus into minus, it's going to become plus. Now let's go to the fourth element. Fourth element is 0. So ignore this column and this row. You're left with element 1. 1. What is the sign? Plus. So plus 1. So now we'll take the transpose. Transpose is interchanging the rows and columns. So it's going to be 0 minus 2, 3 1. This is adjoint of matrix A. Now there is a shortcut. You can avoid all of these steps to find the adjoint. The shortcut is, whenever you have a 2 by 2 matrix, you take this principal diagonal or leading diagonal. This from left side to the right side. This diagonal is called the principal diagonal or leading diagonal. Take the elements, interchange them. So 1 0 will become 0 1. And this particular diagonal, you just change the signs, reverse the signs. Here you have minus 3, it will become plus 3. Here you have 2, it will become minus 2. That's all. So in just few seconds, you'll get the adjoint of 2 by 2 matrix instead of doing all of these. So see, if you apply the same trick, same shortcut, right? What's going to happen? Instead of doing all of these steps, you can take 1 0, right? Interchange. Then 2 minus 3. It will remain 2 and 3 itself, but the signs will be opposite. Here it was plus 2, it will become minus 2. Here it is minus 3, it will become plus 3. So we got the same thing, right? Same thing. This is the way to find the adjoint of 2 by 2 matrix using a shortcut. There are two notes here. Interchange the elements in the leading diagonal and then change the signs of elements in the other diagonal. So these two are shortcuts to find the adjoint of 2 by 2 matrix. Now let's take an example. If matrix A is given, matrix B is given, find adjoint of AB. That is, you have to first multiply A and B, then find the adjoint of that product. Find the adjoint of AB. So first we'll multiply A into B. So A into B would be 1 into minus 1 plus 2 into 0. Then we'll go to the second column, 1 into 0 plus 2 into 1, 3 into minus 1 plus 4 into 0, 3 into 0 plus 4 into 1. So we'll get minus 1, 2, minus 3, 4. So this is the product of A and B. Now we'll find the adjoint of AB. Remember to write, we represent adjoint as ADJ, right? Adjoint of AB would be, now we'll use that shortcut, right? We'll have to interchange this leading diagonal. So it's going to be 4 minus 1. Now we'll swap the signs, right? Swap the signs. So instead of 2, it's going to become minus 2. Instead of minus 3, it's going to become plus 3. So we have found the adjoint. This is the adjoint of AB. So with this, we have come to the end of this particular topic. Thanks for watching.